Today I will share with you information on the Cassini-Huygens mission to Saturn and its moons. The Cassini mission was a massive undertaking. From its sheer size to the amount of distance it has traveled to the amount of data it's gathered, everything about Cassini is big. Over its lifetime, the vehicle processed millions of commands from Earth, sent back hundreds of thousands of images, and traveled over 2 billion miles. The Cassini satellite was named after Jean-Dominique Cassini, whose most notable achievements as an astronomer are the discovery of 4 of the moons of Saturn and also the gaps between the outermost rings of Saturn. The Huygens lander, destined for the surface of Titan, was named after the astronomer who discovered Titan, Christian Huygens. The Cassini satellite was originally expected to orbit Saturn for about 4 years. However, it actually ended up completing 13 years of observations. The Huygens lander still sits today on the surface of Titan. All in all, it took Cassini a total of 7 years to reach Saturn, using 2 gravity assists from Venus, 1 from Earth, and a further gravity assist from Jupiter just to get to Saturn. During this time, Cassini took many detailed images of these planets, including Earth's moon and several asteroids. The Cassini spacecraft had many major components that made up the satellite. Some of the most prominent are the propulsion system, the communication system, and the power system. The largest component by far is the Huygens lander itself. Cassini's movements are governed by the main engine on the bottom of the craft, as well as several directional thrusters positioned throughout the structure. The main engine is used for large changes in the orbit profile, delta V maneuvers, or change in velocity, such as interplanetary changes. The directional thrusters adjust how the spacecraft is pointed in 3 dimensions, equivalent to the pitch, roll, and yaw used when talking about aircraft orientation. Cassini maintains communication with NASA's deep space networks via its radio wave subsystems, as well as its antenna subsystem, which is made up of its high-gain and low-gain antennas. The high-gain antenna is the large dish that is noticeable in any figure of the spacecraft. For power, Cassini is powered by 3 radioisotope electric generators. These generators are run by plutonium dioxide, a radioactive fuel source material, which allows the spacecraft to run independently of any source of sunlight, removing the need for any solar panels. Now, by far the most ambitious portion of the Cassini-Huygens mission was the landing of the Huygens probe on the surface of Titan. This was the first time a probe ever landed in the outer solar system. Once landed, Huygens was able to take over 37,000 images and record a surface temperature for Titan of negative 290 degrees Fahrenheit. Once the Huygens probe has entered the thickest part of Titan's atmosphere, it was time to deploy the Huygens descent control subsystem. This system was comprised of 2 separate parachutes, the first being used to slow the vehicle down to Mach 0.6, and the second being somewhat smaller to allow that phase of the descent to go quickly due to concerns about overall limited battery life for the lander. Once on the ground, here you can see some examples of some of the photos that the lander took. As it was descending, it got several pictures of the surface of Titan, and you can see some of the drainage patterns, which are interestingly enough the methane channels rather than water because of the temperatures. And here, after landing, you see an example of kind of a dry methane riverbed photo that was taken by that Huygens lander. All in all, this was a momentous mission with a lot of discoveries. All references, photos, as well as information are included here for reference. Thank you.